This is an APMT 2009 question based on a concept work for energy. Let's read out what is the problem is. A body of mass 1 kilogram is thrown upward with a velocity 20 meters per second. It momentarily comes to rest after attaining a height of 18 meters. How much energy is lost due to the air friction is the question asked. Let's try to understand what he is saying, right? A body is thrown vertically up with a velocity of 20 meters per second. Means at this point it has only one energy, kinetic energy, because it's at the base, its potential energy equal to 0. How much energy that it has? Kinetic energy is half mu square. Mass is given as 1 kilogram, u is given as 20. So that is 400 by 2, that is 200 joules. So what we can say? That's kinetic energy. That implies total energy at the beginning of the journey is 200 joules. Energy has to be conserved. So at any junction, it shall have an energy of only 200 joules. Now it was moved up. After traveling a distance of 18 meters, its velocity becomes 0. So what we can say? Next, when velocity becomes 0, it is at a height of 18 meters from the reference point. It implies total energy there is potential energy plus kinetic energy. Potential energy is mgh, but it came to rest, so kinetic energy is 0. So total energy there is mass is 1, g is 10, h is 18. That is 180 meters. As per our understanding, here the energy is 200 joules. But by the time it came here, it has only 180 joules of 180 joules of energy. Means what? That remaining 20 joules of energy must have been lost in overcoming the friction, because there is a friction that is opposing the relative motion, air friction. It implies as energy need to be conserved, we can understand that total 200 joules at the initial journey is 180 joules at a height of 18 meters plus energy lost due to friction. It implies energy lost due to the friction is 200 minus 180, that is 20 joules. That's the answer for the problem. So while you are solving the problem, we have used a very simple concept that energy conservation. In any body, at any situation, energy is always conserved, right? There is no situation where energy is not conserved. It's a very basic law of the nature that at any instant we don't have any clue, we can definitely apply the conservation of energy. There are basic things. Just I want to tell you that 5 things in the nature are generally always conserved. Mass is conserved. Energy is conserved. In translatory motion, when no external force is acting, momentum is conserved. In rotatory motion, when no torque is acting, angular momentum is conserved. And finally, charge Q is also conserved. So in any problem you got stuck and you don't know what to do, what to solve, how can I use the not data is not sufficient to solve this problem. We can look into any of these conservations and see whether the helps are in any way, right? Thank you for watching.